Well, hello, it's Cliff here from Down Under. In this video I'm going to have a look at a little budget Chinese 2-inch chuck. I've always been intrigued by these little chucks and I finally got around to getting one, and I'll be giving it a close look and letting you know what I think of it. Well, it's finally arrived all the way from China. 2-inch 3-jaw chuck. Right, let's open her up. Bubble wrap. It's always nice. Opening up something new, exploring new horizons. Oh, it's in a plastic box. That's always a good sign. So I always think if someone's gone to the trouble of sourcing a box or making a mold and getting a special injection molded box for something, that probably means it's a large production run and high volume production, and high volume production probably increases the likelihood of a more thorough design. Well, let's hope so. So let's have a look inside. Oh, a little piece of engineer's jewellery. Well, let's all have a look at that. Quite nicely machined, isn't it? A good surface finish. The jaws look ground. Superficially, it looks good to me. And the proportions look good. It looks, for its size, it looks well proportioned and really solid. Well, before I pull it apart, let's see what we can learn from it as an assembly. Operates quite smoothly. What's the play like in the jaws? They're a little bit loose, but they're not rattling around massively. So how good a fit is the jaw in the T-slot slideway is really critical to doing accurate work. And it feels promising. A little bit of sideways play. It's not so serious. But the lengthways clearance in the Z direction of the lathe, the racking in the Z direction seems like a pretty good fit. I'll check that when I get it apart. A little bit in the sideways this way, but you know, only 2 or 3 thou. The other way, the critical way, that way, feels pretty good unless it's running on burrs and things. But they all feel pretty similar. Oh, my hopes are up. It's early days yet, but I'm quite hopeful that it's quite well made. And I like the proportions. A couple of things concern me. Why do the jaws have such deep cutouts in them and are so sharply tapered in the front here? That's unnecessary for engineering work that I want to do. It just weakens it. But perhaps I can modify that. Anyway, let's pull it apart. So there's a circlip on the back. And then this pulls off. So that's the scroll. And the scroll is a little bit loose on its bearing, but not massively. Thou or 2 clearance. That's not too bad. and the scroll itself looks quite well proportioned. Quite a chunky thread. Of course, the bigger the size of the thread, the less crests you get, the less teeth of engagement. Let's have a look at the jaws a bit more now. So they're free to slide out. So let's have a look in this direction, that way, the critical direction. Yeah, it's pretty good, because that's the way the jaws rack when you tighten the chuck. They rack like that when you tighten it, and so you want a close fitting slideway there, T-slot slideway, and in that direction, that one's very good. So's that one. So's that one. Maybe a thou or so clearance, but not massive. The other way, that is that way. Yeah, it's a little more loose that way. In fact, you can probably see it. That's not so important though. Yeah, they've made the production go a little bit more quickly by having more clearance there. That's more like 3 thou clearance. Anyway, the important direction, that way, is good. Let's have a look at the jaws. See, they've got a double ellipse shape of engagement that goes in the scroll, and that allows you to turn the jaw around to reverse the jaw that way or that way, to have it that way or that way. But the trouble with that design is that you get a very small amount of contact area. You're really only getting a little tiny patch of contact. You're not getting a big arc of contact. On a larger heavy-duty engineering chuck, you're getting a much better matching curve there, and they don't have reversible jaws. They have 2 different sets of jaws or an insertable part that's reversed. So I don't know how well those little teeth will wear and how much force they'll be able to take. That's of a little bit of concern for me. For machining tool steels and so on, you need to have quite a lot of strength and force transmitted through the scroll into those teeth, and with there only being 2 threads most of the way around, 2 of those little patches of contact won't transmit very much force, which is a bit of a pity, because the rest of the chuck is very well proportioned, and that is the Achilles heel of it. Also, the clamping edge is very reduced by those cutout notches. I don't know why they do that, unless it's sort of started off as being a design for holding soft materials like wood. There's not much of a surface area left there. If they're through hardened rather than case hardened, I may be able to grind that back, take a couple of millimeters off that surface to get a bigger surface of contact. So there's 2 sort of weaknesses in the design of the jaw that look to me like the Achilles heels, and mean that it probably can't do very heavy duty work. But I'll assemble it up in the lathe and try some cuts and see. Hopefully I'm wrong, and hopefully it'll be a bit more rugged than I expect. The overall proportions of the body. So if you have a look at this body, as far as I could see when I was looking at it online, it's pretty chunky. The weakest point down here, see if I can show that, down in there, there's about 4 millimeters of steel all the way around there, The rest of the body is pretty solid. So for a 2-inch chuck, that's a pretty integral chunk of metal, and quite a lot of machining involved in that. If it's all accurate machining, that's worth quite a lot. So I don't know how they're making this for the money. The scroll is quite chunky, decent proportions, decent sized teeth. Pretty pleased with that. It's just the jaws, those little teeth on the jaws, with that very small amount of contact, that compromise that allows them to be reversed between inside and outside, means that there's just a little patch of contact, and if you tighten them up too much, they could break off or form over or wear rapidly. Yeah, that and the very much cut away internal surface, the contact surface. Well, let's have a closer look at these parts. So the jaws look like they're made out of steel, and they're magnetic, so I think they are. They look like they're cast or forged or sintered and then machined. I'm not familiar with those processes, but they're not machined out of solid. They've had some sort of forming process. It would be nice if these were really hard, because they are subject to a lot of stress. No, they're not glass hard. A fire will cut them quite easily. I've got this way of checking to see whether something is of low hardness. I've got this piece of P20 steel, which is high tensile steel, about 30 Rockwell C, and it will scratch mild steel. This is a piece of mild steel, and you can see there it's scratching mild steel. So I can tell whether something is harder than mild steel. So let's see if we can scratch it. Let's hope it won't scratch it. It won't scratch it. So it has had some sort of heat treatment process, but it's not glass hard. You know, it's probably high tensile type of hardness. You can see it's been machined, probably with a carbide cutter, and that oval tooth profile's been machined with a carbide cutter. These faces look like they've been face milled or face ground. It's made out of a tough piece of steel, but not glass hard, which is a little bit of a pity, because these teeth are subjected to pretty hefty stress loads, wear loads. When you're holding small tool steel parts, you really want that, ideally that steel to be around 50 Rockwell C, perhaps not as hard as a file, but getting up there, and it's nowhere near that. It might be around 30, if I'm lucky, 40 Rockwell C, but still, it's not rubbish, it's not mild steel, it has been heat treated. The body doesn't look hardened either. I'm not sure if that's been just CNC machined in bulk. See if I can just file it somewhere where it's not too critical. No, it's not hard either. It's not up around the hardness of a file. But still, let's try it here on the back with our little testing tool. Yeah, it's scratching it. So, but not deeply. So it might be about the hardness of the testing tool. It might be about 25 or 30 Rockwell C, or the Brunel equivalent is more appropriate. But you know, something like 1045 steel, perhaps this has been made out of, a bit better than mild steel, I would guess. And probably the same goes for the scroll. Yeah, that's not hard either. But it's not scratching very easily, so perhaps that's made out of a bit of high tensile steel. Okay, so not too bad. They haven't used rubbish, but it's not high-end hardened and ground either. Well, let's have a quick look online. So this is AliExpress. This is the one I bought. It doesn't have a brand, but there's several sellers selling this product, and so I'm guessing it's manufactured in bulk at a factory in China, perhaps for mini lathes. This particular seller is offering them for a good price of 36 New Zealand plus 15 shipping plus GST, about nearly 60 New Zealand dollars. That's about 40 US. I see there's another one that is branded. That's a San-U, however that's pronounced. And if you have a look at the jaws, they're better proportion. Perhaps I should have got one of those. If you're considering it, it might pay to pay a little bit more. The notches are not so deep and the angles are better on the jaws. They may be of better steel, they may be a better chuck, I don't know, but they're a lot more expensive. That would be about $100 with shipping and GST, or perhaps about 60 or 70 into the US. So you've got the San-U and this other brand. They're available in a 2-inch or 50mm, and also available in 65mm. That's a little bit bigger. That might be a good option as well. But this is the cheapest option for me anyway, and the fit of the jaws is quite good. They're sort of high tensile steel, so it wasn't a bad deal, but perhaps the San-U would have been a better deal. I just don't know. The jaws and the jaw slots are numbered correctly, 301, 2 and 3, so I assume you start with the 0 mark, engage 301, rotate the scroll round, engage 302, further 303. So that's good. Clearly identified, to get them in the right order. Obviously the little sets of teeth are offset to allow for the 3 different positions of the spiral, and probably ground concentric in that setting. So it's important to install the jaws in the correct sequence. Okay, well, let's do a couple of quick accuracy tests and check for distortion and so on. So we'll bring the dial indicator in line with the base. Dial in the chuck by tapping it. And we can check it this way. We just tap it around until we get it in alignment, in angular alignment. Tighten it up in the chuck once it is in angular alignment, and then I can dial the whole chuck that is mounted in concentric radially, because I have my chucks floating on the back plate, so I can tap it until it's concentric. So first get it in angular alignment, tighten it up, and then float the chuck on the back plate until it's concentric that way. Once it's running true in both directions, then the chuck itself is running true. And we can put a little part in there now. And the moment of reckoning, is it concentric? This is the first time I've checked it, so this is new to me too. Let's have a look. Just doing this quickly for the video. I'll look at it more closely off camera, but just trying to show you what I'm doing. So I'll bring it in here and let's see what it's like. Wow, I'm impressed. So they've clearly ground those chuck jaws concentric. That's within 1/100th of a millimeter, within half a thou, and I only dialed the chuck in to within, 1/4 of a thou, so it could be even closer than that. But that's pretty impressive. There's a bit of serious machining going on there for what is 30 or 40 US dollars. How do they do it? Alright, well, let's try an actual machining job just quickly. There's a couple of pin tools that come in the box, and you tighten up the scroll by engaging them in the body and in the scroll, and then just tightening it and just simulating it there. So I've just put in a piece of P20 steel. That's high tensile steel. It's about 30 Rockwell C, pretty tough, but let's give it a decent try. I'll do a facing cut across there. I'll just zoom you in a bit better. Okay, we're going to put a cut on, a reasonably heavy cut for a little chuck. Let's just see whether those jaws have a hissy fit. It's a carbide tool, and they're not letting go. They're staying concentric and they're holding it tight. And obviously there's a limit to how big a cut I can take, but it's a little chuck for little parts, and it can take little cuts in tough steel with a carbide cutter just fine. Well, I've just been holding it on the body for this video, just some quick tests. I want to make up a harden and ground mandrel that screws into the internal thread and locating spigot in the back of the chuck. It's an M14 thread. Hopefully that thread and locating spigot are equally accurately made, and then I'll be able to hold the chuck more quickly dialed in concentric in my precision chucks. So that's a project. Another project I'm thinking of doing is grinding the internal jaws with a step in them and putting a thrust pin in the end of that mandrel, and that will turn it into a kind of a lantern 3-jaw chuck. If you're familiar with a lantern chuck, very handy for holding small headed parts. You know, when you want to hold something with a head, an ejector pin, a punch, a headed part, a screw or a bolt. I've always thought if I could modify a little chuck with stepped jaws, that could be a really handy tool for holding difficult shapes. And so stay tuned. I plan to make those modifications, and if it's successful, produce a video. Well, thanks for watching that video. Hopefully you found something useful. If you did, don't forget to like and consider subscribing if you're not subscribed already. Catch you next time.